Hi, and welcome to a Calculus 2 video on integrating by parts or by parts integration. And we're going to talk about two different problems. The first being a solving without solving type of integral. I'll show you what that looks like here in a second. And the second being where we're going to actually do a W substitution first. So kind of some of these other types of by parts. So before I get into the solving without solving, let me show you something that you hopefully do know how to do, and let's link it to that. So let's go off to the side here. And if I gave you the linear equation 3x equals, I don't know, say x minus 5, okay? And I asked you to solve this equation for x. I would hope that it would be pretty easy for you to see that I will subtract x from both sides. I will now get 2x equals this negative 5 if I drop it down, and I can divide both sides by 2. And I hope with some relative ease you could come up with x equals negative 5 over 2. Okay, but what were you really doing here? Well, I was combining like terms or isolating my variable. I had what I was solving for on the left and what I was solving for on the right-hand side of that equal sign. So you have to get them both on the same side of the equal sign, so then you could combine like terms. And once you combine like terms, you got the 2x equals, and the only thing left on that right-hand side was that negative 5, and then you were able to divide by 2 because you are solving for 1x, not 2x. So let me show you what this means in a very oversimplified version of if I had 3 times some antiderivative equals this antiderivative of f of x dx, same antiderivative, right? So I'm saying basically that this x in this linear equation is this antiderivative now. That's the only thing that I am changing. My process is still the same. On the left-hand side, I have 3 of the antiderivatives. On the right-hand side, I have 1 of them. So I'm going to subtract one of these antiderivatives, again, assuming that that integrand is the same. And I get 2 of these antiderivatives. And then again, you are probably trying to solve for one of them, so you would divide both sides by 2. And now I know what this antiderivative of this function will be. Now again, this was possibly an oversimplified version of what I'm about to do, kind of, but not really. What you're going to notice is that whatever antiderivative that you might be solving for, you end up with the same exact integrand while you're doing the problem and while you're doing your by parts integration. So then at that point, we can stop doing our integration, combine like terms, and usually the answer from there is pretty straightforward. So let's take a look at what I mean. So this solving without solving is for use when integrating using by parts integration technique, and the original integrand, literally what you started with, occurs again. So combining like terms is necessary. The other way that you're going to tell is if you were using your by parts integration and one part does not break down and I'll show you what I mean here in this first example. Meaning your new integral is not necessarily easier than the previous. It's actually the exact same level of difficulty as the previous one. So let's just look at standard by parts. Remember, we're going to choose a u and a dv. So I'm just going to start with the basic idea of Leate. If you remember that, it is who should be your u. So if I just go in standard form here, trig is the t, e is the exponential. They're both at the bottom. it really does not matter which one you have be your u and which one you have be your dv. You will get this correct either way. I'll just say for our purposes here, since this liate was who is your u, I'll stick to that. So I'm going to say u is the trig function, therefore dv should be the rest of my antiderivative here, my integrand, which would be e to the 2x dx. Then I will do the derivative on the left. So the derivative of trig is also a little bit easier sometimes for us to do than the antiderivative, so this may be nice. So the derivative of sine x would be cosine of x dx. And then since I have dv over there, I will want to find v, or integrate, on the right. The antiderivative of e to the 2x is e to the 2x, but then since the derivative would have to be times 2, the antiderivative will have to have a 1/2. Okay, so here I go, standard by parts. So I'm going to copy my original integral. That's what I'm trying to solve for. And this will become u times v. So I'm going to write the 1/2 e to the 2x in front of sine x, just for ease of reading, minus the antiderivative of v du. It doesn't matter if you put the dx inside or outside those parentheses. Okay, well, kind of how I can tell that this is solving without solving is you see that your e's are never really going to break down to anything other than e, and then your coefficient changes depending on if you are differentiating or integrating, but e is still always going to be e to the 2x. And same thing with the trig function of sine or cosine. Whether you do a derivative or antiderivative, it turns into sine, then cosine, then sine, then cosine. Of course, you have positives and negatives involved, but it's never going to break down and kind of go away. So that's how I can tell it's going to be of this form. So I'm going to leave that 1/2 in there. And if I do this correctly, I should only have to use by parts one more time to see this solving without solving happen. So I'm going to say u is now cosine of x. I'm going to stick with the u equals the trig portion. And the dv needs to be the rest of that integrand, which I'm going to keep the 1/2 with this. So 1/2 e to the 2x dx. The other thing I'm going to recommend, and again, this is take it or leave it, it's a recommendation, so I don't have to distribute later. You see this negative in front of this whole integral? You can associate it with one of the factors, and then you never have to worry about distributing it later. It will be a part of it because truly you have a plus now in between. So I'm going to make my dv be a negative 1/2, and that way I don't have to worry about trying to remember the negative, or should it be a negative, should it be a positive, etc. So, all right, on the left I will do du, derivative of cosine x is negative sine x dx. Don't forget your negative there. And then my v will be the antiderivative. Well, the antiderivative of e to the 2x is itself. You're going to have to divide by another 2, so that's going to make a negative 1/4. Okay, so now I have uv minus the antiderivative of v du. I'll have to be careful with my signs, but I'm going to copy down the left-hand side. I'm going to copy down my first term. So I will now evaluate my last here integral. So this was uv. So again, I have this minus 1/4 e to the 2x times cosine x minus the antiderivative of v du. I'm just going to write it all down and then do some simplifying if I want. The other thing is, if you write this down, you can always go back later and find your error. So for example, I have a negative in front, negative, negative. So I have 3 negatives, so this will stay a minus. You can pull out the 1/4 if you want to see it. This term would get carried down, this term would get carried down, and this equals this whole antiderivative that I'm trying to solve for. Okay, well this is that solving without solving part here. I have minus a fourth of these antiderivatives. The antiderivative, the integrand, is e to the 2x sine x dx. Look over here what I'm trying to solve for. It's the exact same integrand. It's e to the 2x sine x dx. So these are the exact same integrals. So you want to combine like terms. So I'm going to add a fourth of this integral on both sides. So that gives me 5/4 of these, because 1 and a fourth is 5/4 equals my first term, which I've had for a long time, and my second term, which I got just a few steps ago. I'm going to go ahead and put plus c, but you're going to see now that the only thing I need to do now is multiply both sides by 4/5, because that will make one of these on the left. And then your entire right side there needs to be multiplied also by 4/5. If you want to distribute that 4/5 in, you can, but you certainly don't have to. If I do, 4/10 becomes 2/5. And then when you distribute that 4/5 over, you do get a 1/5 for a coefficient there. And there's my answer. So the solving without solving actually just takes a long time in what you're writing down. But I really want to emphasize that you are just solving, if I can scroll over for just a minute here, you are really solving a linear equation that you've solved and known how to do for years and years and years, I'm guessing, by this point. And I'm just relating it to, okay, what if my variable, or what I'm trying to solve for, is now this antiderivative? Well, you're going to have so many of them on one side of the equal sign or of the equation, and so many of them on the other side, and your idea is just to combine them together and solve for one of them. Okay, so solving without solving might seem pretty tedious, but overall, it's really not that bad. Be very careful in whether you choose to do a trig derivative, so a derivative or sine or cosine, or a trig antiderivative. Again, make sure that you're applying any chain rule or w-substitution in those derivatives and antiderivatives, as well as make sure your positives and negatives are matching. Okay. So what other types of by parts could there be? Again, sometimes we don't necessarily see that a problem will look by parts, and this is going to happen when you get to things not just like this one, where it's an antiderivative of sine of square root of x, but what if it was antiderivative of inverse sine of square root of x dx? I'm going to start this problem the exact same way because I'm going to try to substitute out that square root of x first, okay? So I'm going to say let w, because again, if I'm going to a by parts formula, we like to use u's and v's in our by parts, so I'm not going to confuse that with another u substitution here. I'll just do a w substitution. So I'm going to let w equal the square root of x. Now this is a statement that you can use as many times as you need to throughout our problem. So we might come back to that here in a little bit. So then I need dw. Okay, well dw, since that's x to the half, would be 1/2 x to the negative half, or 1/2 rad x, and don't forget your dx. And if you do want to see this, I think this is worth it. I will multiply both sides by 2 rad x, so I can see exactly what dx will become. Okay, so let's say you're pretty proud of yourself at this point. You're like, I think I'm on a roll. Here we go. I'm doing well. I now have the antiderivative of sine instead of square root of x. We're going to go back to our let w equal statement. So I have sine of w times dx. Well, the dx portion is 2 rad x dw. And hopefully in Calc 1 or Calc 2, either one, you see an issue with this. We are in single variable calculus, so we need it all to be in terms of w. Okay, so that means this square root of x has to go. Well, what do I do with it? You can't just scratch it out. Oh, look. You specifically said w equals square root of x. So use that again. So I have antiderivative of sine w. That's one nice, neat part, or part of the product, right? One factor. And I have 2, and square root of x is really w, dw. So I'm going to do this one using tabular integration. So for those of you that have learned tabular, I will make one column for u's, and I will do the derivative as I go down. I'll make one column for dv. I will do the antiderivative as I go down. And I'm doing all derivatives and antiderivatives, not dx in this case so far. I'm doing them with respect to w. Okay, so if I let u be 2w, derivative of 2w is 2, derivative of 2 is 0. Therefore, the sine of w, again, dw, is my dv, and I'm anti-differentiating moving down. So the antiderivative sine w is negative cosine w, and the antiderivative of negative cosine w would be negative sine w. And so I just carefully write what this is going to become. Here's my uv minus the antiderivative v du, but that's the antiderivative figured out. So this will be negative 2w cosine w minus 2 sine w plus c. And don't get too carried away or excited. Your w, like you identified at the very beginning, right? Your w is square root of x. So in place of all of the w's, I will put square root of x. And it might look a little bit better if you have those angles in parentheses, but there is your final answer. So sometimes if you just do a little u substitution or w substitution first, you'll really make your problem a lot more workable and maybe even easier to see what your technique for integration is. This will wrap up our series on biparts integration. I hope you found it helpful. Thanks for watching.